Hello and welcome everybody to this Sintratec Talk. Now we are joined by Alex Hussain of 3DChimera, our certified Sintratec partner from Miami in the United States of America. Good morning, Alex.
Hi there. Good morning.
Good. So, Alex, how are you personally doing today?
Doing all right. Doing good.
Good. So for people who do not know 3DChimera or yourself, can you give a short introduction about yourself and what 3DChimera is doing, basically?
Yeah, absolutely. So I'm the co-founder and CEO at 3DChimera. We are a advanced manufacturing company based down in Miami, Florida. We distribute a wide range of equipment to our customers. So 3D scanners, 3D printers, 3D software. And we work with them on a consulting basis to help optimize those systems for their problems or challenges they have in their business. We also do some service work with that same equipment. What makes us unique is that we're all engineers here, myself included. So we're very, very technical. We like to get into the weeds on our customer applications to really help use this technology to really unlock the potential of what you can do with it.
Cool. So thank you very much for this introduction, Alex. Well, these days, COVID-19 is on everyone's mind. So we hear frightening news from the US. Can you maybe, as a local person, describe the situation or what's your daily experience?
Yeah, absolutely. So, COVID definitely has changed business. That's for sure. Day-to-day life, I would say it's starting to get a little bit back to normal, but yeah, as hotspots pop up, it's always a bit of a scary situation. As far as the 3D printing business goes, it's one of those industries that I think is actually benefiting from the crisis as COVID has sort of taken hold. We've seen many of our customers, particularly those in small and medium-sized businesses, have their supply chains absolutely decimated. And what they've been able to do is adopt additive manufacturing to completely reinvent their business. And so while it's sort of crazy outside, it's been an interesting time for the business and an opportunity to work with a lot of newer organizations for our team.
Okay, good. Very interesting. So from your personal experience now, so these days you mentioned that the local production is maybe shifting or coming a bit back. Before in the past, we often relied on third-party countries where the value chains have broken down, and it's very important for small, mid-sized businesses as well to keep the pipelines going. So do you see these as a challenge to let's say, establish or do this shift in terms of making sure that the industry is able to do that, is able to use the technology, maybe the new technology, not the conventional ones?
Yeah, there's definitely a learning curve for organizations that are looking to bring in additive as a production methodology. So I'd say the vast majority of our customers, they're either like completely outsourcing to another country, let's say China or something of that nature. And, between the cost of duties and shipping and then just the crazy logistics of this type of scenario, those supply chains were sort of cut off. So in some cases, our customers had to almost like relearn how to make things again, which is actually kind of awesome for us because additive creates all these new opportunities for how you might like completely redesign something. So in some cases, their partners might have the plans for something and not be able to share that back. So there's a big opportunity to work in reverse engineering and not reverse engineering a competitor's part, but like strangely reverse engineering your own part. And in that scenario, these guys then have the opportunity to optimize the design, make whatever minor improvements they've been wanting to make for years. And they're realizing the benefits of no cost for tooling, right? So, on products where you're making a couple hundred or a couple thousand a year, additive makes a ton of sense, especially when we're looking at the SLS technology and especially when your parts are kind of smaller. And so, we've been seeing a lot of folks who are willing to go back and redesign. In some cases, that means, building out a new skill set or improving a skill set in CAD. Certainly, it's learning a new tool, right? And especially in the case of SLS, almost nobody really has familiarity with that in their day-to-day business. Some folks have outsourced that, but, before companies like Sintratec, the cost of it is like super prohibitive, particularly for small and medium-sized businesses. So sometimes these guys have experience with like FDM 3D printing, maybe like a small desktop FDM. But this is a real shift. It's like when that technology shows that additive has potential, but can't get the job done. That's where SLS kind of comes to the rescue and says like, okay, we can actually make production, we can make end use parts, we can make beautiful finishes that are totally acceptable for end use parts for sale in the marketplace.
Okay, that's interesting because from our experience, we have witnessed some kind of a 3D printing hype for a short period of time because many people knew the FDM printers, the SLA printers. SLS is more or less not in everybody's minds these days, but now with this unfortunately COVID-19 hype about what 3D printing can help and support into bringing parts locally and fastly back again, it was an interesting shift that we have seen as well. So we have seen other companies, for example, in Europe, like one of our customers, Materia in Italy, was basically used the Sintratec S2, so the laser sintering systems to produce some kind of adaptional parts for masks, for breathing masks, if this is the right phrase. And this was a very interesting point from our perspective to see that print services, if you would like to call them like them, have made sure that apart from the huge machines that they already installed, they needed fastly some kind of an express service they have had to install. So was this something that you have somehow seen or experienced in the US as well, that people not just change the technologies, that they have been willing, to put on new technologies, to get the risk as well, to invest maybe new technologies to make sure that they fastly can help to solve this big global crisis that we are having now?
Yeah, I think in the U.S., supply chains were like really just not ready for the COVID crisis, particularly in March and as we kind of went through, I guess, that Q2 time period. So lots of companies utilize additive to do all sorts of really interesting things. Our company included. So, we were working on face shields. We were working on some of those like snorkel adapters that you're describing. Actually, really, really interestingly, one of the doctors that like invented those snorkel adapters, it's like literally in Miami, right down the street. So like he came knocking on the door, and we would co-develop a bunch of stuff with him. So yeah, for sure, it's been an interesting thing to see. But we're starting to see now are companies who are actually adapting their business to work with the crisis. So, for example, we have one customer who makes some type of a product that is like a lighting system that is normally like a headlamp. And what they've done is redesign their product to have this headlamp and also hold a face shield, right? And they're actually using SLS 3D printing to produce these parts. So they went through other iterations of refining this design, this headband, to hold their light, which is how they make money. That's their business. And obviously, the market today, you need protection when you're using that light, whatever the case might be. And so they've adapted it to work with these face shields. And so, yeah, we're definitely seeing companies evolve and change in ways that we've never seen really any like external event like cause businesses to completely like retool what they sell. But with additive, I mean, it's literally like spend an afternoon and click a button and you have the new product. It's not like the old school where it takes 6 months or a year to bring a new idea to market. I mean, these guys are able to turn on the dime. And that's why I think we're seeing the interest, particularly from the small and medium-sized businesses. In the US, we have this idea of like pulling yourself up from your bootstraps and like really buckling down when there's a challenge. And the whole idea of the American dream is to like, dig your heels in when there's a problem and like, work your way out. And we're seeing these small and medium-sized businesses do exactly that. And that's like enlightening, or like it makes you feel good as just a citizen here, seeing that the companies are doing that, the people are doing that, and that we're able to be a part of that by providing the technology that enables them to do that.
All right. Are there any governmental programs who are supporting these small, mid-sized businesses by investing in new technologies and making sure that they get this knowledge more fastly than in the past, maybe?
Yeah, I wish there were more. There are definitely some interesting programs that you can take advantage of at this time frame. So we're close to the end of the calendar year right now. So in the U.S., we have this thing called Section 179, which allows businesses to basically deduct the entire value of an equipment purchase off of their tax burden for the year. So that's super, super valuable for particularly small and medium-sized businesses that are evaluating their tax burden. It gives them obviously a de facto discount on their equipment by not having to pay taxes on those dollars. And it was always intended to stimulate the investment in business equipment, and that's working. In many states, there are like research and development tax credits. So you're using an equipment for R&D, even if it's just for a percentage of your time, you can deduct, there's some mathematical formulas that vary by the states, but you can deduct that from your taxes as well. So there are those types of programs that are helping, but there's no like national program of like, let's invest in manufacturing in the way that we'd like to see. We do have some groups in additive that are ramping up a little bit. So during this whole COVID-19 crisis, there's like an incubator group in the U.S. That's called America Makes, and those guys are like a nonprofit organization, and they're definitely sharing tons of information. They took the lead in coordinating and distributing all the COVID-19 relief and qualifying designs for approval with the FDA and through the National Institutes of Health in the U.S. So we're definitely seeing an increased amount of awareness there. But there's not like a fund that you can go dip your finger into and get some new equipment.
Okay.
I hope maybe that's something we see soon, but today we're seeing a lot of businesses who are fortunate to be in manufacturing and see some growth here through COVID, take those profits, if you will, and reinvest that in their business.
Okay, that's very interesting. That pretty much, apart from the governmental program, is covering our experiences in Europe or in Switzerland particularly. We have seen since the crisis started that especially the multinational corporations, so all of the huge ones, they have frozen their budgets for investments. And luckily, not just for Sintratec itself, for I think the entire Swiss economy, the European economy, the small mid-sized businesses are willing to invest and fastly get this knowledge to make sure that they will keep up to date when the crisis is over and have an additional benefit to offer to their customers. So is this, I think in the US it's called the Fortune 500 companies, isn't it? So is this something that you are on your daily work, if you call customers, experience as well then, that it's more or less the small mid-sized businesses who are taking over now, not the control, but the charge in terms of pushing these technologies inside of the country?
Yeah, absolutely. Yeah, the Fortune 500 companies, they're a huge part of our business under normal years. So, we're a small team based out of Miami, but we have partnerships with great companies like Sintratec, and our product offering is somewhat unique. And so we are able to distribute to customers across the entire nation. And yeah, very often I'd say maybe 25 to 30% of our business is tied up in Fortune 500 type of organizations. And yeah, we saw like a faucet turn off when COVID started. Like 100% of the funding has gotten frozen. I mean, the good news with those organizations is they're still planning to make investments. They're just looking into 2021. So, they're still planning for growth, but a lot of those organizations have been very conservative in bringing staff back. They didn't have as much access to like some of the funding that helped small and medium-sized businesses in the beginning. Like in the US, we had a program called PPP, which is the Paycheck Protection Program. And that was super helpful for small and medium-sized businesses, even our business. But big businesses didn't have access to that. They had it more in the form of like tax credits and things, and it was less direct. So yeah, they're being way more conservative about it. But yeah, the small and medium-sized businesses, I don't think they're even buying to sort of like just be ready. I mean, they're buying and they're leapfrogging the competition. So as the big companies are effectively, surviving on their momentum, they're sort of asleep at the wheel, while the small and medium-sized businesses are able to come in and scoop up huge chunks of market share. So yeah, we're seeing businesses that even just a year ago were like a one-man shop in a garage, expanding tenfold in terms of their capabilities to distribute products to their customers, because they're able to be agile, right? For them, it's an overnight decision. Like, one or two people on the management team make a decision and they're ready to rock and roll. I mean, a big company, you have dozens of people and, groups that have to make decisions, and even just getting all those people on a Zoom call is like almost impossible, much less like making a decision. So yeah, we're seeing a lot of momentum with those small, medium-sized businesses, and like I said, that's like super great. I mean, we understand that better than just about anybody, being a small team ourselves. So we're really able to relate, and in the service side of our business, we're not seeing that drop off. So on the service side, we do see our Fortune 500 customers, they continue to grow their business. So they're operating, they're just not investing in new equipment.
Okay, it's very interesting because the majority of our small mid-sized customers, these are hardworking people who actually work their shift, and after the shift is done, on CNC technology machines or whatever, they invest a lot of free time in having fun and bringing passion on learning these new technologies faster. And this is a really, really fun part when people are calling at 8 p.m. at night and asking questions. I think this is really a hard leading thing. All right, so let's talk about selective laser sintering in particular. You and especially 3DChimera have been a Sintratec partner now for many years. So, what do you think? Where do you see the market developing in the next 1 to 3 years? Because, as I stated before, FDM is mostly commonly known to everyone. SLA is very commonly known. SLS, from my experience, is something that people are still struggling to understand the differences. We're explaining them, of course, if we get around to. But we feel that more and more people now starting to do this shift, as you mentioned as well, from desktop or benchtop systems down to professional systems in a specific price and effort range. And what do you think about this? What is your experience?
Yeah, I think what we've seen is a dramatic shift of our customers from prototyping activities generally with 3D printing. And I think when you think about FDM, right, it's like particularly good for like kind of bigger parts that are in really low quantities, right? So like a large singular jig or a fixture or like a big prototype. FDM works fantastic for that, but you could be looking at, hours or days to produce parts. Whereas what we're seeing with our customers in SLS is really seeing a transition to end use parts, right? So actually producing the final product. And so in those scenarios, not everything is a great fit, but certainly when you're looking to print like a lot of smaller parts where you can fit hundreds or even thousands of parts in a single build overnight, that's a real game changer for what you can do in production. I mean, if you're producing 100 or 1,000 parts in an evening, I mean, that's rivaling traditional manufacturing and avoiding completely the tooling cost. So, we're seeing customers who are saying, for the cost of like one tool, I could buy an entire Sintratec S2 and do a dozen products, and like that's amazing. And instead of doing a minimum order quantity of 10,000 pieces and waiting 6 weeks, I can get the 500 I need tomorrow, and then I can move on to the next design the next day, and I can fill out my product offering with a whole variety of things really quickly. So I think we're seeing this hard shift towards end use production parts, which then opens up this whole interesting opportunity for like different types of post processing and finishing on the parts as well. So we know, of course, as people who work in the industry, that when you're taking out a nylon part out of an SLS 3D printer, they look pretty amazing right out of the box, right out of the machine. But there's so much more that can be done, and like we're exploring that like a lot here on our team. So we can't even help ourselves from kind of getting into the challenging applications. So, we've been exploring things with ceramic coatings and with metal coatings and waterproofing and looking at different finishing techniques when you're blasting the parts or polishing the parts to really create this huge variety of finishes that can be done in an affordable way. So it's pretty exciting to see.
Okay. And if you must break it down into 3 bullet points, so where do you see the 3 biggest advantages in selective laser sintering, and where do you see the 3 biggest disadvantages with selective laser sintering? This is a question I'm often asked by my clients, and yes, so more than happy to hear what you're thinking about it.
Okay, yeah. All right, way to put me on the spot there. So, in no particular order, let's see if we can go here. So, to me, really, the biggest advantage is the ability to print a large volume of parts in a very short period of time. So, the fact that we can three-dimensionally stack parts inside of the build volume really gives us a crazy advantage that is almost impossible to wrap your mind around if you're really focused in the FDM or SLA world. So, we find ourselves doing a lot of explaining to people that filling out the build volume and packing it densely is where you get the efficiency from, because a lot of folks approach this with sort of that mindset of like, I have a footprint and then I can build up or out from that footprint, but I can't build on top of each other and stack together. So if you imagine if you can print a couple marbles on a tray on an FDM printer, that's all you can do. But in SLS, we can put a whole bag of marbles and print them all together in the bag at the same time, and that's a pretty big difference. So I think the efficiency of pushing parts through is one key thing. One of the other places we see a massive advantage, I guess our second point, would be parts that are super highly detailed, and particularly those that have thin walls. So we have a lot of our customers who have like really small devices. Maybe they're like Internet of Things, right? There's like a lot of on-body devices. There's a lot of really small plastic housings. I mean, like tiny things with like, number zero screws and, really tiny things that come together. And what's really neat about SLS is, the only option, they couldn't even prototype that stuff. They had to, basically, commit to tooling and get those things injection molded. And a lot of times, you order those parts, I mean, the volumes got like astronomical because like justify the cost of shipping, overseas, and to keep the vendors happy with super small parts, you had to order tens of thousands of pieces, at least a pallet's worth of parts. And sometimes these guys are just starting out, maybe they need only a dozen, and maybe they only need 2 dozen for their trial run, but they couldn't even get a prototype. And so those designs now, they're able to take that CAD, right? So they'll go open their SolidWorks or whatever. They don't have to worry about going in and changing the draft angles or the rounds or the wall thicknesses. Like actually, like basically every rule for injection molding is like amazingly perfect for SLS as well. And so we're seeing this really interesting transition for super fine detailed parts printing perfectly well on the SLS printer. So if the first thing is, pushing out a large volume of parts, maybe the second largest advantage is to put really finely detailed parts in there. And the third advantage that we're seeing is that SLS parts are shockingly robust, right? Particularly out of the PA12 material. So there's all these super hidden mechanical properties about this that even you guys, I mean, nobody's talking about. So like we have one customer who is printing PA12 parts and putting them in an environment where they're exposed to liquid nitrogen. And he called us and said like, hey, I put it in liquid nitrogen and slammed it with a hammer and it didn't break. Did you know that? We're like, no.
Okay.
I mean,
Love to see it then. Okay,
yeah.
That sounds like an amazing case study then, yeah.
Yeah. So low temperatures work great, right? As we know, PA12 works at high temperature applications. So, we have customers who are doing under the hood applications in vehicles now, which is like crazy, right? In FDM, you can't even really do that without a super specialty material and a very specialty machine, much less a really detailed part. We're able to do that. So we're seeing guys that are starting businesses out of their garages with SLS 3D printing, and they're competing with the big guys. Right, it's crazy. Like you can go on like Amazon, and some of the products you're buying are printed on SLS 3D printers. Some of them on Sintratec machines, and they're competing with the big companies, for actual, functional parts. We did a test recently where we did this contest for the U.S. Air Force, and we were trying to optimize a part for strength. And that particular part we were printing, we had done an FDM 3D print with a glass fiber reinforcement because we thought, boy, that's going to be the strongest part. We make these like little test coupons that are kind of like a figure 8. We hang some weight off of them. We found that the straight PA12 part printed off of a Sintratec machine with like literally right out of our sample kit box was stronger than the part we had spent like, I don't know, we were on our 35th iteration of optimizing the design for strength. And like we were trying to eke every bit of performance out of it. In the straight PA12 part, no fillers, no magic, no special settings, was stronger right out of the box. So I think there's a lot of hidden potential there for strong parts, for high temperature, for low temperature, and all sorts of crazy things with chemical resistivity that people are just starting to get their heads wrapped around. And so the potential is almost limitless in what you can do. You combine that with like the idea of maybe taking into account lattice work or generative design, which sounds great on paper, but if you try to do that on an FDM 3D printer, like good luck. Like you're gonna be breaking away supports your whole life, and you're gonna have weak parts. That's not the case of what we're seeing on the SLS technology. So crazy geometries, like that stuff that like your brain can even barely imagine. We can start to see that show up in the parts, and it really helps these guys to not only set their parts apart in terms of what they look like, but you get massive performance gains as well. So those I'd say are probably the 3 top things, I guess, right off the top of my head. As far as like, was it the disadvantages you were thinking about or asking about? So I would say maybe not a disadvantage, but just something to keep in mind, and that people don't always realize is that when you're coming from an FDM background, you're often thinking about making really dense parts, right? You wanted to make a sheet of something, you'd basically make it very thick, and it's going to have like a low density infill pattern on the inside, and that allows you to get like a lightweight part. Well, in SLS 3D printing, because we're basically sintering the powder, we're basically doing everything one layer at a time. So when you have a big blocky chunk of geometry, that doesn't work so good in the technology. So there's a bit of a learning curve there for folks, and I'd say that's one of the challenges that people have to wrap their head around. So if you're used to designing for, let's say, like a milling application or for an FDM application, you're going to have to rethink those design rules. The good news is that you get to like open up the creativity, not close it off. But the bad news is that like if you've got really chunky parts that have big, thick cross sections that work great in FDM, those might not be a one-to-one transition over to SLS. So, designing for the process is probably one of the biggest challenges, probably the biggest challenge, I'd say, right off the top of my head. Maybe the second thing might be the overall lack of material options out there. So in the FDM world, obviously you have the vendor specific materials, and those work good usually. But now we're starting to see all these big multinational plastics companies getting into the open materials game. And that's really very quickly ramping up the material options in the FDM space. In the SLS world, we're not quite there yet. So, while we have some machines like the Sintratec kit, which are basically completely open material systems, in fact, we have lots of people developing new systems today, there's not a great marketplace for open materials at the moment, at least in the US market. And so that's something that I think is lacking and can be a little off-putting to folks as they're entering the space. But I always encourage people to look even just at the basic materials we have with Sintratec. That PA12 is way more diverse than people think, as is the TPE material. You can do some really crazy stuff with those two materials that not a lot of people know. So we're always looking to you guys to help us bring out new materials and ramp those into the systems. And soon, I think we'll be looking to the open marketplace. I feel like COVID kind of put a damper on that. I bet we're all about a year behind where we'd like to be. And then let's see, what would be maybe the third thing? Well, I think there's a disconnect maybe that people broadly have with SLS 3D printing and thinking about the size of the machine. So often when someone's buying an FDM 3D printer, they're thinking about printing the largest part possible on that build platform, right? So if they're buying a printer that's got a meter build platform, they want to build parts that are a meter in size, right? And that's because you pretty much have to have the parts stuck to the build plate. Whereas in SLS, I mean, sure, you can print a singular part that fills the whole volume, right? But that's not where you don't get any real advantages over other technologies by doing that. Where you get the advantage is having a lot of smaller parts in that same volume. And so that's also a thing that people really have to kind of learn and wrap their head around. So it's not really a knock against the technology as much as it's just like a big piece of missing information out there that we really have to educate people on. So I always say SLS is great for a lot of small parts. It's okay for a few big parts. Whereas FDM is great for a few big parts, but is terrible for a lot of small parts, like almost impossible usually. So it's there's a trade-off, right? And it's not gonna be the same tool for every application.
So, Alex, I think we're coming to the end of this discussion. Are there any final words from your side about the cooperation with Sintratec itself, and maybe for other international partners, why they should become partners of Sintratec as well, or why it's worth to do it?
Yeah, sure. Yeah, well, first off, thank you for having me here. Super excited to share these ideas, and I hope that it's been educational for folks. Overall, our experience working with Sintratec has been really fantastic. The technologies are a real game changer. We have little to no competition in the marketplace for a printer at this level of quality and the price point that we offer it. And so, if there are other like organizations out there who are looking to add products to their offering, I think you'd be hard pressed to find anything that's going to have the level of quality and performance, really the industrial performance that you can get out of a Sintratec system anywhere near the price points that we're able to offer that. And so While it's great for partners to expand their product line, and I think it opens up huge amounts of opportunities and doors, it's also incredibly valuable for our customers as well. And it for those same reasons, it allows them to really leapfrog the competition. So when a big company is looking at investing in technology, we're often helping them to bring in a bunch of Sintratec machines, but sometimes they opt for a much bigger system. I mean, you could be talking about systems that are 10 or 100 times the cost in order of magnitude. So it's like really a crazy difference. So for a fraction of the cost, you can be competing with those kinds of guys. So it's been great with this technology. It's proven to be our best-selling product this year. I think perhaps last year as well. And we hope to see that to continue to grow into next year and to really help a lot of these businesses around the curve here and come back to health here after this COVID crisis, which has sort of crippled everybody. Yeah. So we're looking forward to seeing what our partners and our businesses can do here.
Okay, good. So thank you very much, Alex, for your time, and thank you everybody for tuning in. If you have any questions, do not hesitate to call us, write us an email, or contact us on social media. And of course, make sure that you visit sintratec.com, and especially if you are from the US, that you go to 3DChimera.com to share some thoughts with Alex, or maybe take profit from this fantastic consulting that he's doing. Thank you very much for that. And this was all that I could say today. Thank you, Alex, very much.
Thank you.
Appreciate it.
Thank you, guys.
Bye-bye. Bye-bye.
Bye.